Hello, ladies and gentlemen, Kincaid here, and we are going to solve some quadratics or solve some equations that have x squareds in them using a process called completing the square. And you're probably thinking, well, why would we have to do this, Kincaid? Like, why do we have to know another way to get two solutions? And the answer to that is because sometimes factoring doesn't work. Sometimes we can't just go right to this whole let's break it apart. X, I need things that multiply to make -20, like -10 and +2. Yep, they still add to make -8. And then that's where we would set each of these beautiful guys equal to 0, and we'd get two solutions, right? X equals 10, x equals -2. Two totally different answers. That's when we have an x squared and an x in it. We can try to break it apart using factoring. If I don't have an x term, I can just solve by taking a square root. You know, I'd add that 5 over, and I'd have x squared equals 12, square rooty. I end up with like 2 square roots of 3, x equals, throw a plus or minus in front to make sure that we have our two solutions, right? So both ways we get this two solution idea. Well, what happens when neither of those works? This has an x squared and an x, so at first glance I'm thinking, all right, let's factor this guy. So x, in the back I need to multiply to make 1, 1. However, when I check this, inners, outers, and there's only one way to multiply to make 1, I don't get the 4x in the middle. So factoring doesn't work. And I can't solve by square rooting because I have an x term and an x squared. So we have to have another way to get our two solutions. And that's where completing the square comes in. Remember when we talked about filling in that blank or finding that C, that last number there in the process that completes the square, makes it factorable? This is why, okay? So these are the problems that are in your little foldable there. Make sure you're following along. Let's solve this one using a process called completing the square. And remember, you already looked at what that meant visually with those little tiles, right? And how you can complete the square. If you have an x squared and 4x's, we found that you would need 4 little ones in order to complete that square. So here's what happens. We were used to the process of filling in the blank with a certain number that would complete the square, literally, right, with those tiles. So what's happening here is we have a 1 in the place where the blank is. So we need to move that 1 to the other side. So I'm going to place that 1 to the other side, and doing so I make him negative. And now I have a blank in that space. So what number needs to go in this blank in order to complete the square? Remember when we made this visual, it was x squared and we had 4x's, and then we completed that square with the number 4 because half of this term is 2 times itself makes 4. So 2 squared makes 4. So I'm going to add a random 4 out of nowhere, that wasn't even in this problem at all, to this side of the equal sign. But if I do it to that side, I must also do it to the other side. In order to complete the whole idea of being equal, what I do on one side of the equation, I have to do to the other. So when I do that, over here I have -1 plus 4 makes 3. Now on this side, I've created something that is now factorable. What number or what things would go in the front of these two factors? X and x, right? To make x squared. In the back, what multiplies to make 4? And adds to make 4 in the middle? 2 and 2. So we end up with x plus 2 times x plus 2, which is the same thing as x plus 2 being squared. And that equals little 3 on the other side still. So now how can I solve for x now? Notice that I don't have x in two different places. I just have it in one place. And I can get x alone now by using our whole square root idea. I can get rid of the squared by square rooting, which leaves me with x plus 2. And over here, the square root of 3 just stays the square root of 3. I can't break it apart. But I do need to put a plus or minus in front of it to note that we had two solutions here. And now last but not least, to get the x alone, I'm going to subtract that 2 over, and I have x equals -2 plus or minus the square root of 3. So two separate answers would be -2 plus the crazy decimal, the square root of 3, which is like, you know, -0.3 something something something, and -2 minus the square root of 3 is my other answer. which is like negative 3 point something 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 in my calculator. Okay? So we end up with these two crazy decimal values, but you can just leave them like this together as one expression. Okay? Let's take a look at that second example there. We have the same idea, x squared minus 12x plus 4 equals 0. So remember what this would look like. We'd have an x squared, we have 12 little x's, so we'd probably split them 6 over here, 6 over here, blah, 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 bad drawing. Okay, and we end up with thinking about what number would I need in order to complete that square. But first, I need the blank to place that number in. So I'm going to move that 4 to the other side, making it negative 4. And then I'm going to add space for that blank. So again, what's half of negative 12? Negative 6 times itself makes 36. So 36 is the number I need to add to both sides, because I can't just add it to one side. It has to stay equal, equations. So I need to add 36 to both sides in order to make this expression factorable over here. So on this side now, I can now factor him into x and x. What is 36? Like what multiplies to make 36, but would add to make negative 12? Negative 6 and negative 6, right? And on this side, I just have 32 now, because negative 4 plus 36 is 32. So this side I can write as x minus 6 squared. You're right, those should always be the same. Otherwise, we can't write it as squared. And here we have 32. Now, if I square root both sides, x minus 6 is left here. The square root of 32 I need to break apart. That's the square root of 16 times 2, which would give me 4 square roots of 2. And in front we need to place plus or minus, because we need to note that we had two solutions before I took that square root there. Don't forget that those are two solutions right there. So now I'm going to add 6 to this side, and I have x equals, and here you're going to leave this as 6 plus or minus the crazy decimal 4 square roots of 2. And you can just leave your answer just like that. Ooh, just like that, without the crazy line through it. All right, last one, completing the square when there's a number in front of the x squared. Now notice I have 2x squared plus 8x plus 14. This one I can't complete the square, ladies and gents. This is very important. Unless this term, x squared term, has just a 1 in front. We can't have a 2 there. Because if I had 2 of those x squared pieces and I put them like this, I can't make a square with that. That's too rectangular. I can't build a square around that. So I need to make sure that I have 1x squared on every single problem. And that means before I even start doing anything, I need to divide everything by 2 to make that happen. So 2x squared is now x squared. 8x is now 4x. 14 is now 7. And here I have still 0. And now I'm ready to do the whole let's fill in the blank. X squared plus 4x plus blank equals negative 7. What number goes in the blank? Half of 4 is 2 times itself makes 4. So I'm going to add 4 to both sides. Here, this is now factorable. X plus 2, x plus 2. And here on this side, I have negative 3. So this is x plus 2 squared. Here I have Mr. Negative 3. And now I square root, x plus 2 plus or minus. Ladies and gents, I have a negative inside a square root, so I'm going to have an I as part of my answer and leave the square root of 3 as it is because it doesn't square root nicely. And it can't be broken apart. So now I'm going to subtract the 2, and I have x equals negative 2 plus or minus I square root of 3. There we go. That's a beautiful answer for our third example there. So on the front of that little foldable, let's kind of summarize this process. What's nice about completing the square is that it's a process that gets repeated over and over and over. Every step is sequential. There's nothing that you do differently at any given time. It's always the same thing. So here are those steps that we did on all 3 of those problems. First thing is make sure the lead coefficient, the x squared, has a 1 in front of it. If it doesn't, you might have to divide if it doesn't. divide by whatever's in front of that x squared to get the process started. Then you need to move the c, or the regular number, to the other side. We call this making room for the blank, so that you can fill in the blank. So complete the square on the left and add to both sides. Remember, when you complete the square, you say, what's half of that x? And then you square it. So the half of the x term's number now, not the x itself, but the number in front. You take half of that and you multiply it times itself, add that to both sides, and then you go from there and you solve. And that includes factoring and taking square roots. And always remember that you should have that plus or minus involved. So completing the square, what's nice about it, like I said, is that process. It's the same thing over and over and over again. And that's going to lead us to where we're going next. When the process is repeated over and over and over again, eventually somebody comes up with a formula. And that's going to bring us to that quadratic formula later, okay? So these are the three additional problems that are in your foldable. Make sure you do those. Okay, do not skip this part. I want to make sure those answers are good, and that you have this process down, and then you have some additional work to do. Okay, thank you. I want to thanks for taking good notes. Kincaid out.